Today, in our Rust discussion series, let's discuss something which is very fundamental in Rust, which is ownership and borrowing. I was talking to a friend recently, and he said that in Rust, when you give something to a function, you also transfer the ownership. You no longer own it after that. And that kind of piqued my interest. And as we already talked about, in Rust, things are immutable by default. So that one I knew already. But when he said ownership, you no longer own it after you call the function with a variable. That kind of like what's going on here. So that's ownership and borrowing are two pillars of Rust that help it basically implement memory safety. So we look at these two examples. One is object on heap, as you can see here. We have object on heap.rs and we have object on stack.rs. And we'll see how the ownership concept and borrowing concept come in handy in talking about these two different kind of objects. So let's take something like primitive types that so in here we have to understand one thing, that when objects, when types are primitive types like integer or floats or string literals, it's possible that they can live on a stack. But when you have things that can only live on heap, then we have uh, memory issues start coming. Because as you know, the stack is a very efficient data structure which is just scope based and automatic allocation and deallocation. When the functions come and go, things can get allocated and deallocated. But heap is a data structure which is not automatically managed. We have to understand what's going on there, how much memory is there, how many blocks are there, how much free space is there, things like that. So without further um, discussion, let's look at an example. So let's look at this program object on stack.rs. And why are we calling like that? So let's look at, so here what happens is, if you look at main function, we have a very local variable x which is mutable, but it's local to the function man. It lives on a stack. And since primitive types implement copy semantics, so when we say let y equal to x, actually the value of x is copied to y. And when I call this function, I borrowed it. This is the function name. I gave it a reference to y, because let's say I wanted it to modify it in some ways. What happens if I build it and let's say rust c object on stack.rs? You said cannot assign to. You said no, you're not allowed to change a immutable reference. As we know, ampersand refers to a reference. So I borrowed it as a function that takes immutable reference. But then you tried to do funky stuff with it. You said star s equal to, like in C style, changing the value of something through by passing the pointer to it. Say no, you cannot do that unless you make your intentions clear that you are giving me a mutable reference. You didn't give me. You actually gave me a immutable reference. So in order for that to compile and see how if the y really changes from original value that it would get 32 to 332, we have to have a couple of things. So let's make it mutable as the compiler is telling us. Okay, mutable. Now for that means we have to make the function signature, otherwise we'll have a function signature mismatch. So now let's try to compile what it says. Cannot borrow y as mutable as it is not declared as mutable. So now there again in Rust everything is immutable by default comes into play. You cannot change y, you cannot give y to a function, so say hey go and change it, because it's a mutable reference, you're allowed to change it when y is not even declared as mutable. Y is a constant value. You cannot give reference to a constant immutable value. So let's make it mutable. Now I think it will compile, and it did. So we saw just things related to immutability, and as we said, it did change. So integer passed is, as you see in function here, integer passed was he said 32, but he changed, and then we printed y here, and we did get 332. Maybe we should write here y now is, so if you see here, and y now is 332. That is happening after the function call, and that is integer passed is 32 is inside the function call. So that was integer passed is 32, but we changed it to 332, and then we try to again print it outside. No problem. So after you did immutability, you have to make these two changes. First of all, you have to make the variable mutable, and then you have to have a mutable reference to the function, because otherwise without the mutable reference you will have more issues. So now imagine you want to change it but you don't have a mutable reference. So let's make it a regular function. Okay, no mutable. Now you see, okay, now let's try to compile, see what it says. He says that it says S is a reference, and obviously it's a mutable reference, not the mute reference. So the data it refers to cannot be written. So this immutability, mutable reference, references we already talked about, very, very important in Rust. Now the most important, the ownership and borrowing affect us even more when we have things that are handles and they point to the locations of memory in heap. So we'll look at one of these examples. So object lives on heap.rs. Now here you see interesting the concept. So we have a x string that is there is a string, and as you know the strings live on heap. This is not a literal string, remember. So this is allocated string lives on heap. Now you see ownership of the handle transfer to y. Now here this transfers ownership, something like when you have a handle and when you select y equal to x, it's no longer the same as if they were primitive types. You can't copy, because the objects that live on heap, they don't implement copy semantics by default. So they're like moved. So the ownership is moved to y. If you move to y and then after that you try to even print it, even print ln here. See, if nothing else, do nothing. Let's say after transferring the ownership, we say print. Would it compile? Say no. Ownership value moved here. When you do let y equal to x, the handle ownership of x, it was a handle actually. It doesn't have, even though it seems to us coming from the older languages, C and C++, that hey, x is there, I should be able to print it or do something with it. At least printf should be allowed, right? You would think that print should be allowed. I'm not trying to, hopefully the print is obviously is not trying to change it, but you can say no, value borrowed here after move. So function is basically transferring the ownership. You cannot, after moving x, the see, he's saying the error was borrow of moved value. The value was already moved to y. How can you try to print it after that? And the reason is, if you have handles pointing to the pieces of memory in heap, and once you give the ownership to somebody else, and that too in this case we give a immutable it was not even mutable, it was immutable. uh, the handle was copied to y but immutable. So now uh, things could change if you give somebody a immutable. If you copy your, if you move it, once you move it, uh, if they change it or something, if y changes after that, what is the meaning of printing here x? Now you could say, well, so what, y is changing but I want to print the original value. But no, that's not how things work in Rust. In Rust, because x is a handle, see, listen, x is not a integer value that, hey, I want to print x like the last example. X is now a handle pointing to some piece of memory over there. Now if y also has that ownership of that handle, and y can change that piece of memory through its own handle, then it's not the same thing that, hey, I want to print x, as if it is x is a primitive type. No, x is actually a handle. So once you have handles and point, which in C we used to call them pointers, things start to get complicated. In the sense, the ownership and borrowing concepts start coming. So let's try to uh, comment out that code, and then I think it will build now. Well, after transferring the ownership, now he says, warning, I borrowed it is never used. That is easy. We'll try to fix it. Now another way is not only just copying the things. If you were to so one way to pass ownership is when you say of a handle is when you say let y equal to x. Other is you pass the variable to a function. That also results in things getting the ownership being transferred. So now here you see what happens. He says borrow a moved value. The value is already moved here, but then here you try to print it again. The print is not allowed after you copy it, after you gave the handles ownership to this function. I borrowed it. So again we understood the concept of ownership and references. Now one way to kind of, at least in the beginning, you might say that, hey, this is a very annoying thing that I can't do this. But you could probably have references. You can, for example, let's do this. Let's copy out the previous call I borrowed it, comment out, and let's now call I borrowed it function with immutable reference. Let's see what happens. So now he says, here he said that consider removing the borrow. But here he said, you see, you're supposed to be, you gave, it was immutable reference, right? So if it was immutable reference, how did you, but the function itself, so here we have a function called argument mismatch that we can fix. Let's try to now make the function also take reference, because actually the comment was wrong at this point unless we make it a reference. Okay, we made a reference. Now let's see. Okay, it compiled. So if you have a immutable reference going into a function, and the variable is immutable as well, let y is immutable, no problem. But now we have a immutable reference. But suppose I borrowed it to actually modify this original string to the reference that is given to it. Suppose I say as dot push. That is Rust's way of adding things to the original string. So I say the original string was basically pretty much, if you think about it, hello Rust lover. And then let's just say I have a string here. I'm pushing Astra on top of it. Now you see, I think it will say that, hey, you have immutable reference, and you try to see this won't compile. See, S is a mutable reference, so the data it refers to cannot be borrowed as mutable. So how do we fix that problem? Well, obviously, we would like our functions to change things. I mean, we don't want functions to be completely immutable, useless. So let's call it mutable. Now, of course, unless we want to see the argument mismatch, so we have to pass a mutable reference. Now you see mutable reference was passed, and here it says okay, cannot borrow y as mutable as it is not declared as mutable. So let's call y as mutable. I think now it will let you change y. So let mut y. There you go. It actually changes. So that's one way to make sure that this ownership, borrow, and these things, you know that what is happening, how the ownership of the handle. See here, first the assignment. When you assign x to y, ownership of the handle transfer to y, or in other words, move to y. Then you said, then if suppose there is no assignment kind of thing, suppose you just called, you just gave this variable which lives on heap, which is actually that variable would be handle. You called a function with it. At this point, function call here will also transfer and will result in ownership of the transfer of the ownership. So you have to, so in Rust, ownership, borrowing. So here we started our program for explaining concepts in Rust. We said borrow of moved value not allowed, moved, or you could say transferred value. So it's like if you transfer, it's like a handle or key that you give to somebody with a promise saying, hey, you, that is in case of reference. Like you obviously cannot change a, it's like giving somebody a reference, a immutable reference, and then they try to change. But he says borrow of moved value not allowed. Even without reference, if you transfer the ownership of the handle to, you cannot call the function, you cannot continue to assume that x is still is a valid handle in a way. If you think about it, it's just illegal because you already transferred the ownership to y. So just keep these things in mind. There's a another concept, lifetimes, that we would probably cover in following lectures, following discussions. So with that, I will leave you guys alone, and you're free to think about these topics or these concepts that Rust has introduced: ownership, borrowing, lifetimes, and other things. I would say that we talked about things like object oriented concept, decoupling of data and behavior into two different blocks, right? One with a struct, one with IMPL implementation block, and the interface is covered with traits. I would say them they look more or less like C++, but in a maybe done in a different way. But ownership and borrowing is very fundamental to Rust. So I just wanted to finish this beginning Rust discussion series with this concept of ownership and borrowing. I wish you guys all the best with your Rust adventures, and I hope you never your Rust knowledge always remains current and is never gets rusted. With that, adieu, as they say in French, or in Spanish as they say adios, and in English we say goodbye. So with that, bye bye.